Like most staircases, you can use common components to build a stair assembly, such as rungs, L and U-shaped winders, and landings. For more complex stairs, you can sketch the boundary, define custom treads, and also landing profiles. Steel and timber stairs can be created by using steel stringer profiles and custom tread profiles. Also note that stairs can host reinforcement bar but cannot be joined to other structural elements such as floors. A shaft opening is very useful when there is a requirement to maintain vertical openings that cut through multiple floors. Symbolic lines can be drawn, which are then displayed on each floor that the shaft cuts. In the example shown, the shaft opening is used for lift shafts and also for drainage pipe openings. Our first task is to create a multi-story staircase in this section of the structure. To begin, we define a staircase in a plan view. Let's begin by opening up the 00 ground floor plan. We'll then zoom in to the area where we want to create our stair. You'll note here that we have a reference plane which is indicating the starting position of our staircase. To create a stair, on the architecture ribbon, select Stair. Here you'll note that we're using components, and in this case we're going to use the straight component here. Our intention is to create a U-shaped staircase with a half landing. On the options bar, you'll notice here that the location line is set to the right-hand side of the stair. We're not having any offset from selected positions. My run width is 3 foot and 6 inches, and I'm going to create an automatic landing as I model the staircase. In the Properties palette, you'll note here that we're using an in-situ concrete stair for Core 1. The base level is set to 00 ground floor, but we want to adjust the top level to be 01 first floor. Now when I do this, you'll notice now that the actual rise height is calculated, and also the desired number of stairs is currently calculated at 17. The actual number of rises that are created is reported here in the properties as a read-only value. Before I go ahead and create the stair, I just want to check the railing settings. So on the context ribbon, you'll note that we have the railing tool. Let's select this. We just want to ensure that the railings are set to none, as this is going to be a structural staircase. Let's go ahead and select OK. We're now ready to model our components. To begin, I'll snap to the endpoint of our reference plane, and I can now define my first run. You'll note that on screen is displayed the number of rises created and the number remaining. So in this example here, I'm going to create 9 rises on my first run, and then 8 rises on my second run. In the Properties palette, you'll now note that the actual number of rises matches the desired number of rises. Also, our desired stair height is calculated out at 11 feet. On the context ribbon, let's select Finish Edit Mode. And our staircase has been modelled. To help us understand this a bit further, we're going to create a section that's going to cut through the first run of stairs and elevate the second run of stairs. On the Quick Access toolbar, select Section. Create a section that initially runs down this grid here, and we'll then move this or reposition this over the first run of the stairs. I'll change the section depth here just to elevate the stair itself. We can then go ahead and open up that section. You'll note here that the stair isn't quite high enough to reach the top of the slab. The reason for this is that the run settings have start and end with rise. To edit this, I'm going to select the Tab key just to select this run here. Once I have this run selected, you'll note in the Properties palette we have the option of Begin with Riser and End with Riser. So I want to begin with a rise, but I don't want to end with a riser, so I'm going to remove that. Now this little warning here is now saying that my staircase cannot reach the top of the slab, because obviously here I've told it not to end with a rise. The solution here is to extend the length of the run, which will add another step. Click OK to the warning. And here we'll go back to our ground floor plan. We'll select our staircase. click Edit Stair. I can then select this run of stairs, and I can use the grip here to drag the run end and incorporate another step. If I now select the Finish Edit Mode tool, and once again go back into the section, you'll now note that my stair reaches the slab. Next, we'll create a multi-story stair. Switch into your 3D view, and you can now see that we have our staircase that we've just created in 3 dimensions. Also note here that my levels are displaying in 3D. To create a multi-story stair, select the stair, and note on the context ribbon we have the option of selecting levels. Now here I can use a crossing window to select the levels that I want the multi-story stair to span between. If I then go ahead and select Finish, you'll note that the multi-story stair is created. Something to note that if I select the multi-story stair, I can then connect or disconnect levels if I later on add or remove levels from my building structure. Finally, we create a shaft opening to complete our stairs. Let's switch back to the ground floor plan, and we'll note here that we have our staircase now created. On the architecture ribbon, you'll notice we have the shaft command. Let's go ahead and select that. And now on the context ribbon, you'll note that we have 2 modes. We have the boundary line mode, which is where we draw the plane shape of our vertical shaft. And then we have a symbolic line mode where we can draw symbology to represent an opening. Let's begin by creating our boundary lines. So the shape that I want to open is going to be across here, and it's just going to incorporate the staircase itself. In this example, we're not required to create symbolic lines. In the Properties palette, you'll note that we can set our base constraint for the shaft opening. Notice it's automatically going down -1 foot. The reason for this is so it actually penetrates through the ground floor slab, if that was a requirement. And it's going to also go up to the top constraint. Now currently it's only going up to the 1st floor. I'm going to change this and go all the way up to the 5th floor. Let's then go ahead and select Finish Edit Mode. Once again, to help us understand this, we can switch back to our 3D view, and we can now see we have a shaft opening incorporated into our slab. If we now switch back to our ground floor plan, and we zoom into the core area, you'll also notice here that we have some additional shaft openings that have been created, and these are incorporating symbolic lines. So for example here, if we select the shaft opening, and we select Edit Sketch on the context ribbon, you'll note here that these items have been created with symbolic lines. Each of those openings will then appear on subsequent floor planes. So if I open up the 2nd floor plane, and we also zoom into the shaft openings here, you can see that they're still displayed.